Hello class. Today we're going to talk about an introduction to trigonometry. Okay, so this is going to be a three-part video. In this first video, we're just going to talk about what we call as the trig ratios. Then in the second video, we're going to talk about how do you find the missing side length of a triangle using ratios. And in the third video, we'll talk about how to find the missing angle of a right triangle if you know certain information using the trig ratios. So in this first one, what I'd like for you to do, I want you to do a few warm-up questions. Okay, so I'm going to put a question up. I want you to try to work it by yourself, and then I'm going to come back and we'll discuss how we work it. So this is going to be looking at the information that we already know about a right triangle. So here's our first problem. So it says, I would like for you to find x, and then round your answer to the nearest tenth. So in this triangle, you were given this side length, this side length, and this side length, and we're asked to find the third. So what do you use in order to find x? Pause the video and find x for me. Okay, so let's see how you did. Hopefully you realized when you're given two sides of a right triangle, to find the third side, we're going to use the Pythagorean Theorem. So a squared plus b squared equals c squared. Well, we know the two legs, the two sides that make up this right angle, are going to be the a and the b. So 12 squared plus 15 squared equals c squared. Then we do the math. 12 squared is 144, plus 15 squared is 225, and that's equal to c squared. So we take those two numbers, we add them together, 144 plus 225, enter, you end up with 369. Now, I don't want c, I don't want c squared, I want c. So we take the square root, and you find out that c, square root of 369, is approximately 19.2. In this case, inches. So x is approximately 19.2 inches. So one thing that we know, with right triangles, is that if I'm given two sides of a right triangle and asked to find the third, I can use the Pythagorean Theorem to find the missing measure. Well, over the past few days, we've been talking about special right triangles, and we had two of them. One of them was a 45-45-90, and the other one was a 30-60-90. And we found out that in these particular triangles that there were some special ratios. So in this second question, we are given a 45-45-90 right triangle. And in this one, we know two ratios. We know a leg is going to be equal to the hypotenuse divided by the square root of 2. And we know that our hypotenuse is going to be equal to the leg times the square root of 2. So if I'm trying to find a small thing, I'm going to take the big thing and divide. If I'm going to try to find the big thing, I'm going to take the small thing and multiply. So that's what we'll do in order to find x and y. So in this particular one, we asked two questions. What do I know, and what do I want to know? Well, what do I know? Well, I know the hypotenuse. What do I want to know? I want to know a leg. Okay, so that means I need a leg equals formula. So leg equals the hypotenuse divided by 2. So we take 25, we divide by 2, and we find out that our leg is equal to 12.5, and in this case, feet. Okay, so our x value would be 12.5 feet. Well, we know in a 45-45 right triangle that the two legs are congruent, so that means that my y is also 12.5 feet. Now, we also talked about a 30-60-90. Okay? Now, I'm not going to write the ratios of this one because there's 4 of them, but we'll discuss them. We found out that in a 30-60-90 that we have two types of legs. We have a short leg, which is the side opposite the 30 degree, and we have a long leg, which is the side opposite the 60 degree. And then, of course, we have the hypotenuse. Now, we also found out that in a 30-60-90 that the short leg is the one that's the most important. So from short leg, I can go to the hypotenuse. From short leg, I can go to the long leg, but I can't go from the long leg to the hypotenuse without going through the short leg, or vice versa. So you have to go through the short leg. So in this one right here, we ask ourselves the same questions. What do I know? Well, I know the hypotenuse. So the only thing I can find with the hypotenuse is the short leg. So we know that the short leg, or in this case the x, is equal to the hypotenuse divided by 2. Because we know the short leg and the hypotenuse, they are either the short leg times 2 or the hypotenuse divided by 2 to get it. So x is equal to, again, 25 divided by 2 gives us 12.5. So that tells me my x value is 12.5, and in this case, feet. So in order to find my y, I now know my short leg is 12.5 feet. So now I need to go to the long leg. And we know that the long leg is equal to the short leg times the square root of 3. So we get y is equal to 12.5 times square root 3. And we end up with an answer of 21.65 or 21.7. So 21.7 feet. So that's what we know about right triangles so far. Okay? So we know Pythagorean Theorem. We know special right triangle 45, 45, 90. We know special right triangle 30, 60, 90. But what if you have a triangle that looks like this? What if we don't know two pieces, we don't know two of the side lengths, and it's not a 45, 45, 90, or it's not a 30, 60, 90. What if it's just a regular old right triangle? What do we do? Well, that's what our lesson is about today. Today we're going to talk about something called the trigonometric ratios. Okay, so the word trigonometry means triangle measure. The ratio of the lengths of two sides of a right triangle is known as a trigonometric ratio. To write trigonometric ratios, you must identify sides that are opposite and adjacent to the acute angles of a triangle. Opposite means on the other side of. Adjacent means attached to or beside. So if you look at the example that we have, they've chosen angle A. So they've chosen this angle right here. So when I place that arc, I've identified two things. One, this arc is going to touch the adjacent side. So this side length is going to be called adjacent. This side over here, this angle, or this side, excuse me, is called the opposite side because it is away from or opposite from angle A. Okay? Now, what if we did it the other direction? Here's this same triangle. Here's A, here's C, here's B. Okay, so this is still going to be the hypotenuse always. But what if I chose angle B instead of angle A? Well, then if I chose angle B, this side right here is going to be the adjacent side, and this side right here is going to be the opposite side. So opposite and adjacent are all determined by the angle in which you choose. And you have to understand that particular idea when you're dealing with trig ratios. So let's talk about what those are. First off, where are these going to be found on a calculator? Well, what we're going to be looking for are these buttons right here. The sine, the cosine, and the tangent buttons. Those are the ones that we're going to look for. Now, there are three ratios that we're going to talk about today. Okay, so in this particular lesson, we're just discussing the ratios. Okay, in the next video, I'll show you how to use the ratios. So here are the ratios that I need you to understand. The sine ratio, and that's how we pronounce that, even though on the calculator it's spelled S-I-N, they leave off the E. This is called the sine ratio. And the sine is always going to be opposite over hypotenuse. Okay, opposite over hypotenuse. So basically what we're going to be looking at is the sine of some angle is equal to opposite over hypotenuse. And that's how we're going to be looking at it. Okay, so now really we need to do one more thing real fast. We need to do sine of some number. There's going to be some angle measurement there. It's going to be opposite over hypotenuse. The cosine, which on the calculator is just COS, it's going to be the cosine of some angle is equal to, this one's going to be adjacent over hypotenuse. Adjacent over hypotenuse. And then the last one is tangent. And we represent on the calculator that with a tan. It's going to be tan of some angle. And it's going to be equal to opposite over adjacent. And now in the next video, we'll talk about how we can put those together. So let's look at this in terms of this triangle here. Okay, so we've got sine. Okay, so the sine of angle A, so I'm looking at this angle right here, is going to be the numbers, and we're going to be putting this with numbers, opposite over hypotenuse. Okay, so this angle right here, to do the sine, is going to be opposite over hypotenuse. Okay, now, same thing if I'm going to do cosine. Cosine of this angle is going to be adjacent over hypotenuse. And tangent of this angle right here is going to be opposite over adjacent. So those are the ratios that we'll be typing into our calculator. Now, before we do that, though, we're going to look at kind of a way to remember the ratios. Okay, so this is Chief Sakatoa. Okay, it's not really an Indian chief, but it's Sakatoa, sounds like an Indian chief. So what we basically do is we remember Sakatoa, S-O-H, which stands for sine is equal to opposite over hypotenuse. C-A-H, ka, sa, ka, cosine is equal to adjacent over hypotenuse. Toa, tangent is equal to opposite over adjacent. So if you remember Sakatoa, you can remember the ratios that we have to use. So what I want us to do real quick is we're going to type in a few things on our calculator and learn how to use our calculator to just find what we call a trigonometric ratio. Okay, so here are the problems we're going to use. We're going to do A, B, C, and D. It says sine of 10 degrees, cosine of 75 degrees, tangent of 53 degrees, cosine of 22 degrees. And we're going to look at how we type this in on the calculator. Okay, so again, we're looking at these three buttons on the calculator, where whatever calculator you're using, those are the buttons that we're going to look at. But before we can do anything using these ratios, you have to make sure one setting is correct on your calculator. So let's look at that setting. So I've got a calculator on the right side of the screen. So the first thing you have to do is you've got to type the mode button right here. So I'm going to hit the mode button. And what we have to make sure of is that this area right here, if you'll notice, mine's kind of turning gray there. We come down here to this one right here. Default is to have your calculator in what we call Radian Mode. So what we need to make sure of is that our calculator is in degree mode. So we're going to arrow down until radian is blinking, arrow over to degree, and hit the enter key. And that takes our calculator, puts our calculator in what we call degree mode, which allows us to do the trig ratios. Okay, so now we hit second mode and we'll get out of it. So here's how we type these in to the calculator. So all you're going to do is type in sine 10 degrees. It says sin, but it's really sine. That's how we pronounce it. So you'll do sine, and then inside those parentheses, we're going to type in 10 degrees, enter. And it says round to 4 decimal places. So we look at this one, and we got 0.17364. So the answer would be 0.1736. Okay, then we'll do cosine. So we'll do cosine 75, enter. And you find out that this one is 0.2588, and then there's a 1, so it doesn't do anything to the 8. So you do the last two by yourself. Pause the video, answer those two questions, and write down the decimal value rounded to 4 decimal places. Okay, so let's see how you did. So the next one, you're going to type in tan 53, enter. And this one's going to be 1.3270. And then the last one's a 4, so it doesn't do anything. And then we're going to do cosine again, 22, enter. So this would be 0.927, and then that 1, because there's an 8 there, is going to bump to a 2, 9272. Now these are what we call trigonometric ratios. Now, the ones that we're going to do in the next few videos, we're not going to use the decimal values, but this is a way of looking at the relationships. Even if you may not understand it yet, this is a relationship. Okay, it's setting up that relationship. But right now, I just wanted us to type things in on the calculator. So that's kind of an introduction to trig ratios, okay, which look like those, sine, cosine, and tangent. And we're going to use Sakatoa to help us remember the ratios to put together. So in the next video, we're going to look at how do we actually find missing pieces. So until next time, I'll talk to you later.